Hi guys, welcome to our lesson for 6.5. We're going to look at dividing polynomials in this lesson in order to find roots, or in other words, zeros or x-intercepts. Again, our goal here is basically to come up with a way to um, find the zeros of a polynomial function so that we can graph it in more detail, which is what we're heading towards the end of this chapter. But before we can get there, we've got to learn how to divide polynomials first. So we did addition, subtraction, and multiplication earlier. Those were pretty straightforward. Dividing polynomials is new and much less straightforward. So I think the first question that we should answer is, why do we even want to do this? And there's really two reasons to learn how to do polynomial division. And the first one is what I just talked about. So we want to be able to find the zeros or the roots of any polynomial. So just as an example for you, like imagine I gave you f of x equals 3x to the fifth minus 4x squared plus 2x minus 1. And I said, okay, I want to know is negative 2 a zero of this polynomial, right? Because I want to know if when I graph this, if it's going to go through negative 2 comma 0. Is that going to be one of my x-intercepts? Well, we can use polynomial division in order to answer that kind of question. The other reason that we want to know how to do polynomial division is actually for later on this year. We're going to learn how to find something called a slant or oblique asymptote. You guys have done asymptotes a little bit before. We're going to look at all sorts of different kinds of asymptotes in Chapter 9 when we learn how to graph rational functions. And we're going to use polynomial division, specifically polynomial long division, in order to find slant asymptotes. So those are kind of two reasons why you'll want to become very proficient at these techniques. So we're going to focus on two methods today. And the first method is something that you learned way back in the day. We're going to learn how to do long division again. It's been a long time, right, since we thought about that. The second method is we're going to learn something called synthetic division as well. And both of these techniques have their place. Synthetic division is faster and much more efficient, but it doesn't work in certain circumstances. And that's similar. We've seen that a couple times this year. We saw this with all the different techniques we learned for matrix solving as well. Oftentimes you've got a trade-off between efficiency and whether it can cover all the different cases that we might need to look at. So we're going to start by looking at long division first. And I've got two examples here. One that's polynomial long division, and one that is simply long division from way back when you were much younger. And I want to kind of go through these side by side so that you can see that they're actually exactly the same thing. So let's start by just setting these up in long division form first, right? So we've got x plus 4 on the outside, and then we're dividing x cubed minus 3x squared plus x minus 8. We're dividing that all by x plus 4. And that's similar over here. We're going to be doing 845 divided by 2 so that you can see how these two things match up. So let's start with the original long division, 845 divided by 2. If you remember, the first thing that you do is you look at the 8. You say, okay, how many times does 2 go into 8? And I'd say, well, it goes in 4 times. And then I would multiply 2 times 4 and end up with 8, which I would then subtract. So we're going to do the same thing over here with our polynomial long division. So the question here is, how many times does x go into x cubed? And we just need to worry about the x because it's the higher degree between x and 4. So we're thinking about, okay, how many times does x go into x cubed? That would be x squared times. And then we're going to multiply, just like we multiplied 4 times 2 to get 8, we're going to multiply x squared times x plus 4. And we're going to end up subtracting x cubed plus 4x squared. And so when we do our subtraction, with our long division side, we end up with 45. And with our polynomial long division side, we end up, the x cubes cancel out. We have negative 3x squared minus 4x squared. So we end up with minus 7x squared plus x minus 8. So now we're going to do the same thing again. So on the right side, I'm going to say, okay, how many times does 2 go into 4? I would say 2. So 2 times 2 would be 4, and I would subtract those. On our polynomial long division side, I would say, okay, how many times does x go into negative 7x squared? And my result would be negative 7x. And again, we're going to multiply negative 7x times x plus 4. And that leads us to subtract negative 7x squared minus 28x. So when we do our subtraction here, so obviously on the long division side, we would just pull down the 5. On the polynomial long division side, our 7x squareds would cancel out. We would end up with x minus negative 28x, which is 29x, and then the minus 8 would just pull down. So now we're going to do this again, right? Next step. So how many times does 2 go into 5 on our long division side? And we would say 2 times. And 2 times 2 is 4, so we're going to subtract. And on the other side, we would end up with how many times does x go into 29x? And so we would say, well, it goes in 29 times. 29 times x plus 4, we would subtract 29x plus 116. So now when we do our subtraction here, so we've got 5 minus 4 is 1. 29x minus 29x obviously is gone. Negative 8 minus 116 is negative 124. And so these are our remainders, right? And if you think about the long division side, if you remember, when you end up with a remainder, that's the same thing as adding the remainder divided by the original value that you're dividing by. So in other words, we would just have like 422 and a half. On our polynomial long division side, it's the same thing. We've got x squared minus 7x plus 29 minus 124, that's our remainder, over x plus 4. So in this case, you can see that in this situation, x plus 4 does not evenly divide into x cubed minus 3x squared plus x minus 8. So this is how you do polynomial long division. It's exactly the same as regular long division, just with variables. So our second method is what's called synthetic division. And synthetic division is extremely efficient and fast, but it has a serious limitation as well. It only works for first-degree binomial divisors. In other words, it works for things like x plus 1. It does not work for things like x squared plus 1, which you could do long division for, but you can't do synthetic division for. So there's a limitation here, but oftentimes we are going to be using first-degree binomial divisors. So an example of this would be this problem. One factor of the polynomial function is x plus 1. So that tells us that one of the zeros, right, if you think about it, one of the zeros is x equals negative 1. We want to find the other zeros as well. We know that there should be 2 more zeros because if you think about it from last section, one of the things we talked about was that when you solve polynomial equations, you end up with the same number of answers as the degree. For this problem, our degree is 3, and so far we only know one of the answers. We know x equals negative 1. So the way you set up synthetic division is you basically, we're just going to be looking at the coefficients. So I would take my negative 1, and I'm going to put it in a box to remind myself that that's the division piece for this problem. And then rather than writing down the entire polynomial, we just take the coefficients. So x cubed has a coefficient of 1, x squared has a coefficient of 5. The really important part here is x has a coefficient of 0, and then we have a constant term is negative 4. It's really important to not forget to include the 0 coefficients on terms that are missing, because we need to include those as well to make the synthetic division actually work. So what you're going to do is you're going to leave a space for a row of numbers, and then draw a line underneath. And the way synthetic division works, it's incredibly simple. Basically, whatever coefficient is first, we just drop that. So we're going to have 1, and then we take that number multiplied by the number in the box. So 1 times -1 is -1. We put it over here. And then all we do is we just add down. So 5 plus -1 is 4. Multiply 4 times the number in the box, -1, get -4. 0 plus -4 is -4. Multiply that by the number in the box, come up with +4. And in this case, -4 plus 4 is 0. Now the final number, that number is always your remainder. So if that number is 0, that means the division worked successfully, as it should, because I already told you that -1 was a 0 for this problem. So the division had to work. If the division doesn't work, in other words, if you don't end up with 0 as your remainder, that means that the number you started with isn't a 0 for that polynomial. So this doesn't really look like anything, but the 1, 4, and -4, that's the polynomial result from the division. In other words, if I go back a slide for a second, remember how when we did the polynomial long division on the left, our result was x squared minus 7x plus 29 with the remainder? The x squared minus 7x plus 29, that was the result of the long division. In this case, these are the 1, 4, and -4 are the coefficients of your result. So your result would be 1x squared plus 4x minus 4. Which, as you can see, like that's a quadratic. You guys know how to find the zeros of a quadratic. In this case, you can't factor this, but you could pretty easily use the quadratic formula and you could come up with the other two solutions to this problem. Because the quadratic formula is going to give you the other two zeros that you want to find. So the key here is you can use synthetic division to essentially reduce the degree of a polynomial. We went from a cubic to a quadratic. And a quadratic is something that you guys know how to solve in order to find the remaining zeros. So this is how synthetic division works. So we've learned two techniques, long division and synthetic division. The last thing I want to mention here is how do you check your answers? Well, it's actually pretty simple to check your answers, particularly when for synthetic division. When we're looking for zeros, one way we could check our answers is we could just graph the original polynomial on a graphing calculator, right? And we could use the zero feature to find our zeros and make sure that they actually match. So that's one way. The other thing is you can always just either multiply back out. In other words, you can multiply your result by the thing you were dividing by and see if you get the original function. Or if you end up with zeros instead of, like if you're trying to find the zeros instead of just trying to do the division, you can just plug the zeros back in to the original polynomial and make sure that the answer is 0. So really, it's pretty straightforward to check your answers for polynomial long division problems, and that's always something worth doing if you can. So that brings us to the end of our video for 6.5.